welcome to Study Spectrum. Today we will start with the third chapter of Science and Technology of 9th Standard Maharashtra State Board. The chapter's name is Inside the Atom. Now friends, before we actually move into Inside the Atom, let us understand why there was a necessity or why the scene or the scenario came to understand about the atom or to understand what is inside the atom. Okay. Now if you see in your surroundings, in your day-to-day life, you will find many objects, things which are made up of different shapes, sizes and textures. Now the point to be noted is these objects or things are made up of material which scientists named as matter. The air we breathe, the food we eat, stones, clouds, trees, plants, animals, even a drop of water or even a sand particle. Everything is made up of matter. Now also the important point to be noted is every matter, every object, every matter occupies some space, that is volume, and has mass. So if you want to define matter, how you can define matter? Matter is something which occupies volume and has mass. Correct? Now, we will talk about some of the properties of matter, like physical properties. Now friends, in early stage there were two school of thoughts. There were two types of people. One type of people always thought matter is a continuous thing, like a piece of wood. Whereas the other school of thought or the other category of people thought that matter is made up of particles. Now let us understand with the help of an activity what matter is made up of. Suppose you take a beaker of water, a beaker made up of glass filled with water, say 100 ml of water, and you pour some amount of salt into it, NaCl, maybe 2 teaspoonfuls of NaCl into it, and you mix thoroughly the beaker or the water or the solution inside the beaker. Correct? Slowly what you will observe is salt is starting to vanish. But actually you will figure out, and you know also, that salt has been dissolved into that volume of water. Now where these particles went? These particles of salt are actually trapped between the molecules of water. Correct? Now this activity actually explains us that matter is not a continuous thing, but it is made up of small particles. Now the question arises how small these particles are. Correct? So let us understand this with another activity. Suppose you take a beaker made up of glass, you pour some volume of water inside it, maybe 100 ml, say 100 ml of water you have taken in a beaker made up of glass. Now you add say 2 gram of crystals of copper sulfate, CuSO4. Now hydrated copper sulfate, which means crystals of copper sulfate, are actually blue in color. So if you will add copper sulfate into that volume of water, what will happen? Slowly the whole of the volume of water inside the beaker will turn into blue color. Now suppose you take 10 ml of that solution and pour into another beaker made up of glass containing 90 ml of pure water. You take 10 ml of copper sulfate solution from the very first beaker where you have made the solution of copper sulfate, 100 ml of copper sulfate. You take 10 ml of copper sulfate from that beaker and pour it into another beaker made up of glass which contains 90 ml of water. What will happen? You will find again the volume of water in that second beaker will turn into blue color. Correct? But it is not as bright as it was in first beaker. Now you take another 10 ml from second beaker and pour it into third beaker containing 90 ml of water. So finally you have third beaker containing 100 ml of solution of copper sulfate, and what you will figure out is the blue color in the third beaker is less brighter than in a solution in second beaker is less brighter than the solution in first beaker. It means blue color is more bright in first beaker than in second beaker and then in third beaker. Now finally you take 10 ml of solution, copper sulfate solution from the third beaker and pour it into 90 ml of water containing in fourth beaker made up of glass. Now again you have 100 ml of copper sulfate solution in the fourth beaker. Now you find the color has faded too much, but still there is visibility of very small amount of blue color, correct? Now what you will figure out, the blue color in the very first beaker is very bright, it is less in second beaker, it is more or less bright in third beaker, and it is highly faded in fourth beaker. But still there is visibility of blue color, very small, very partial, but there is still visibility of blue color with the fourth beaker. This tells us that the particles of copper sulfate in that very first beaker is being divided when you keep it into or pour it into second beaker. It is further divided into tiny particles when you pour it into third beaker, and it is very further divided into very tiny particles when you pour it into fourth beaker. It means particles keeps on dividing into smaller pieces. Now what this example, this activity actually tells us? It tells us that you cannot imagine how small a particle can be. It is beyond our imagination, correct? Now this is why from the time the human beings came into existence, they always had a curiosity to explore surroundings. They always had a curiosity to know what is the smallest part of a matter. This is why we were discussing matter first, and then we will move inside the atom. Now, over the years, scientists took hundreds of years to know about atom or what is the smallest part of a matter. Now, if you talk about a compound is made up of molecules. Molecules are made up of atoms. But if you talk about elements are made up of atoms. Okay, when we talk about molecules of a compound, a particular molecule is made up of atoms, combined together to form a single molecule. When we talk about elements, they are made up of atoms. That is how a matter is. Now, many scientists came, they gave their theories, which we will slowly read in this chapter, and how they gave these theories and put effort to discover what is inside the atom. So, over the years, scientists started to explore what is the tiny particle, what is the smallest part of a matter. For example, if you consider our body, a human body has many systems. For example, reproductive system, nervous system, digestive system, and systems contain different organs. Different organs contains different tissues, and different tissues contain different cells. So in biology, if you read this, you will come to know cells are the smallest part of our human body. In the same way, for the very first time, Rishi Kannad, 6th century before Christ BC, said matter is made up of very tiny particles called Parmanu. Then in came a Greek thinker, Democritus, and he said 430 before Christ, 430 BC, that atoms are the very tiny particles of a matter. In Greece, atoms are called as atomos. In Greek language, atoms are termed as atomos. And he said atomos are uncuttable. They are the very tiny particles present in any matter. After these two thinkers, in came for the very first time and very famous theory, that is 1803 AD, Anno Domini, 1803 AD, John Dalton, who gave the very famous theory on atoms. He said in his theory, the very first point he said in his theory, atoms are the smallest indivisible particles present in any matter. Correct? Now, atoms of an element contains millions of atoms, and it means atoms of an element are identical in all properties including mass. But if you take atoms of a particular element only, atoms of different element may differ in mass, but atoms of same element were identical in all properties including mass. He said, atoms of different element combines in a fixed ratio to form compound or molecule. For example, H2O. 2 hydrogen, 1 oxygen. 2 hydrogen atoms and 1 oxygen atom. It means 2:1 ratio. They combine to form 1 H2O molecule. That was the third point. He said atoms are indestructible. They cannot be destroyed, they cannot be created, but they can be shuffled, they can be reorganized to form different molecules. So these were the 4 points, the very famous theory for the first time given by John Dalton in 1803 AD. AD means Anno Domini. The very first point he said, atoms are the very smallest indivisible particle present in any matter. Atoms of same element are identical in all properties including mass. Atoms of different elements may differ in mass. And atoms cannot be created or destroyed, they can be reorganized to form molecules. And also the third point, that was atoms of different elements combine in a fixed ratio to form molecules. Okay, then after John Dalton, another scientist, his name was Thomson, gave a plum pudding model, also called as watermelon model.
No more spending your energy and money on coaching classes or missing classes for rain, for rally and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now, after John Thomson, who gave his plum pudding model and split the atom, correct, to tell us that it is having atom is a gel-like positive sphere and electrons are embedded into it. After him, in came Rutherford with his students, and in 1911 he demonstrated that atom contains a tiny massive nucleus. Now let us understand how he conducted the experiment, what were his observations and what were the results he gave. We'll first try to understand the setup of the experiment, how he conducted the experiment. Okay, now this experiment was actually called as gold foil experiment. I will just write it down here. This experiment is gold foil experiment. Now, there are certain reasons why he chose gold only for this experiment. The very first reason is gold is highly malleable. You can make thin sheets, very thin sheets of gold. And if you make very thin sheets of gold, you can assume you have just single layer of atoms on that thin sheet. The very first reason why he chose gold only. The second reason is gold is one of the least reactive metal. If you go for mining, gold is one of the metal which is found in pure state or native state. Most of the other metals are found in combined state with different elements. Gold is one of the least reactive metal. Okay. Now, what was his setup? He used a screen. See, I am going to display a 2D view of the setup. He used a screen, a circular screen on which he coated zinc sulfide. On this screen he coated zinc sulfide ZnS, which show a property of phosphorescence, or in other words fluorescence. Now, what is phosphorescence or fluorescence? Phosphorescence or fluorescence means whenever a charged particle will hit this screen coated with zinc sulfide, then it will show some flashes. or scintillating behavior it will show, scintillations it will show. So zinc sulfide is basically having a nature to show phosphorescence property, or betterly known as fluorescence property. So he used a screen coated with zinc sulfide. He placed a very thin sheet of gold foil in front of it. Why gold foil? Because very thin sheets of this metal can be made. It is highly malleable, that is a characteristic property of gold, and it is one of the least reactive metal. If you see the reactivity series of different metals, you will find gold is placed at the bottom, at the last of reactivity series. Then he placed lead bricks just before this gold foil. These are lead bricks. Symbol of lead is Pb. Lead bricks. And he used a radioactive element to liberate alpha particles. Alpha particles are double ionized particles. I will just draw over here. It is an alpha particle source, a radioactive element which is going to liberate alpha particles, which is double ionized helium atoms, 2He4. Now what happened? Why he used, we'll try and understand the experiment setup first. We have just understood why he used zinc sulfide coated screen, why he used this gold foil, and that is why this experiment is also called as gold foil experiment. Now why he used lead bricks? Friends, lead has the capacity to hold or accept charged particles inside it. It will not allow it to tear apart the lead material or come out from that lead material. In reality, if you see, or if you ever get a chance to see a nuclear reactor, if you get a chance to read about nuclear reactor, the waste, the dustbins, the waste where nuclear particles are stored, dustbins, that garbage is kept, is made up of lead. Why? Because it has the tendency, the ability to absorb alpha particles or radioactive rays. That is why he used lead bricks with a very small opening between them, so that these random movement of alpha particles will be absorbed by lead bricks, and it will only allow alpha particles to pass in a straight line. Correct? Now, we have seen the experiment setup. This is alpha particle source. This is alpha particle source, any radioactive element. Alpha particles is actually helium, 2He4. So he used an alpha particle source. He used lead bricks with a small opening between them. Why lead bricks? Because it will absorb the random movement, scattered moved alpha particles. It will only allow alpha particles to pass in a straight line between the gap between the lead bricks. He used gold foil and he used a screen, a circular screen coated with zinc sulfide, ZNS, because it has the property to show phosphorescence and fluorescence. Now, this was the setup. What were his observations? He observed that most of the scintillations, most of the flashes of the light when these alpha particles were traveling in a straight line passed through this gold foil, most of the scintillations were shown at the center of the screen. Most of the scintillations were shown at the center of the screen. Very few were deviated through small angles, and scintillations were shown either below or above this central line, and very few bounced back from this gold foil. What were his observations? The observations were most of the alpha particles passed to the straight line, passed in a straight line and hit the screen at the center. That is why scintillations, most of the scintillations or flashes were seen at the center of the screen. Very few were deviated through small angles above or below, and scintillations were shown above or below this center line also. And extremely low number bounced back from this gold foil. So these were the observations which he made from the experiment. Now we'll talk about what were the results he drew from these observations. Now we have just seen the gold foil experiment conducted by Rutherford with the help of their students, which is not mentioned in the textbook, but let me tell you, he took the help of his own student, that is Giger Marsden, which you will come to study as you move in higher standards. He took the help of his own student Giger Marsden to conduct this experiment. We have just talked about the setup of the experiment. What was the purpose of coating zinc sulfide on the screen, why he used gold foil only but not any metal foil, why he used lead bricks, and why there was alpha particle source from radioactive LP. Now we have also talked about observations of this particular experiment. Most of the particles hit at the center of the screen. Most of the scintillations, flashes were shown at the center of the screen, indicating that they were traveling in straight line only, they were not deviated. Okay, and very few were deviated at small angles and hitting the screen, showing the scintillations below or above the center line. Okay, now let us see observations on the basis of which he drew results. I have just written over here in a tabular form. I hope you can see that. I will just read out for you what were the different observations and what results he drew, what is there inside the atom. Correct? He was the second man after John Thomson. John Thomson, who is also known as the man who split the atom for the first time. And after him, in 1911, Rutherford conducted this experiment, gold foil experiment, and drew more results about the inside structure of atom. So what were the observations? The very first observation, like I said, he saw most particles pass in a straight line. Why? Because most of the scintillations were shown at the center of the screen. Most particles pass in a straight line just because most of the scintillations, flashes were shown at the center of the zinc sulfide coated screen. Correct? Some of the particles deviated at small angles. We have talked about that. We have just seen in the experiment setup also. Some of the particles were deviated at small angles below and above also. A very few scattered at large angles. Now the number of alpha particles hitting at the center were majority, a few through small angles and a very few through large angles. Correct? And he also observed that very few bounced back towards the source, alpha particle source, radioactive element. And that number was very small, very small. They were traveling in a straight line and they bounced back at 180-degree angles. Okay. Now what were the results he drew on the basis of these observations? Now if you talk about these results, most particles pass in a straight line, what do you understand? Obviously we can say that most of the space in an atom is empty. If suppose this is an atom, correct, and at the center there is some or the other particle place, which he termed as nucleus, which will I explain later on. So there is a small particle and this is an atom, then most of the space is empty. That is why these alpha particles were traveling in a straight line and most of the scintillations were shown at the center of the zinc sulfide coated screen. So very first result he wrote that most of the space in an atom is empty. Second, he said at center there is tiny positive core called nucleus. He named that positive core as nucleus. It is very tiny, he stated that. Now, why did he say that particular positive core is tiny? Understand. These helium ions, these alpha particles are double helium ions, double positively charged helium ions, correct? They are also positive. Now, you understand, suppose these two are magnets. These finger parts are north pole and these ends are south pole. If I place this way, they will attract with each other. If I place this way, they will repel from each other, correct? Because, see, understand, these finger parts, these two palms, consider them as magnets. These finger ends, say they are north pole of each of the magnets, and these palm ends are, say, south pole of each of the magnets. If I place these two magnets in this fashion, then what will happen? They will attract towards each other. Why? Because these are unlike poles. This one is north pole and this one is south pole. They will attract towards each other. If I place these two magnets in this fashion, what will happen? they will repel from each other. Why? Because like poles, like charges do not attract, they repel. Correct? And also if I place these magnets in this pattern, this fashion, then also they will repel. Why? Because these are like poles. Similarly, in charges, like charges repel each other, unlike charges attract each other. Now, since alpha particles are traveling in a straight line, and had there been a negative charge at the center, they would not deviate through small or larger angles or will bounce back at 180 degrees. They will attract towards each other. Correct? But his observation, see, he was not able to see alpha particles. The only things he can see was scintillations, flashes. Correct? And on that basis, he can give his observations, results, judgment. Right? Now, these alpha particles are positively charged and they are getting deviated through small angles or through large angles. It means if these are positively charged, there must be a positive charge at the center of atom also, which he said is very tiny and positive core, and he termed that positive core as nucleus. Now, why it was tiny? Because most of the alpha particles were traveling in straight line. It means had this core been larger in radius, larger in size, most of the alpha particles wouldn't show scintillation. They will deviate from their path. Correct? And most of the scintillations might have been shown at angles, smaller or larger angles, but not at the center of the screen. But since most of the scintillations are shown at the center of the screen, it tells us that positive core is very tiny. And since they are deviating, that core should contain positive charge. That is why he wrote the result, the second result, at center of the atom there is a tiny positive core, and he named that positive core as nucleus. What was his other result? He said 100% positive charge is inside the nucleus. How? See, understand. Whenever, suppose I say this is the positive core that is inside the nucleus, and these are the alpha particles. Whenever these alpha particles were traveling nearer to the atom, nearer to the positive core nucleus, they were getting deflected. But while traveling away from the nucleus, they were not getting deflected. It means at the center there is 100% positive charge. It means 100% positive charge in an atom is inside that positive core, which he named as nucleus, and he wrote the third result as 100 positive charge inside the nucleus. Also, he gave the fourth result that since an atom is a neutral thing, correct? Atom is neutral, it means if 100% positive charge is inside that nucleus, there should be negative charges outside the nucleus to make the atom neutral, correct? Now, since these electrons, he found that they are very light, it means 99.9%, he gave that result, 99.9% of the mass of the atom is inside the nucleus. So the fourth result he wrote as 99% mass of the atom was inside the nucleus. Okay. Now the last result he said on the basis of analogy of our solar system. He said electrons which are very light and negatively charged species outside the nucleus but inside the atom are revolving around that nucleus in their own paths, and that paths were termed as orbits. Electrons which are light but negatively charged, because they have to be negatively charged because all of the positive charge is inside the nucleus. To make the atom neutral, they have to be negative charge. If they will be also positive charge, then the atom will turn out to be a positive sphere, but atom should be neutral. That is why those electrons are supposed to be negatively charged, and these were light. So he said light negatively charged electrons revolve around the nucleus in circular orbits, circular paths, which he termed as orbits. So what we have seen, what we have talked so far, before getting inside the nucleus, before getting inside the atom rather, which is the name of the chapter, inside the atom, before we moved inside the atom, we have talked about matter, tiny particle inside the atom. Atom is a very small tiny particle inside a matter, and atomos, which was Greek name of atom, is uncuttable and is the smallest particle inside the matter. Then John Dalton, the very famous John Dalton, in 1803 AD, Anno Domini, he gave atomic model in which we have seen different points. Atom is the smallest indivisible particles of a matter. Second, atoms of an element are identical in all properties including mass, but atoms of different elements are different in mass or differ in mass. Third property, atoms of different elements combine in a fixed ratio to form a molecule. I've explained about H2O also. Two atoms of hydrogen, one of oxygen will combine to form a single molecule of H2O. 2:1 is the ratio of hydrogen is to oxygen. And the fourth point, atoms cannot be destroyed or created. They can be reorganized. They can be shuffled to form molecules. Then more scientists started to do research over the atom, and they led to the discoveries what is inside the atom: electron, proton and neutron. The first one to peep inside the atom was John Thomson in year 1867. He gave his plum pudding model. We have talked it before, Rutherford, and he was also known as the man who split the atom. Just now we have talked about Rutherford gold foil experiment. We have talked about the setup of the experiment also. I have mentioned that he took the help of his own students, Giger Marsden, to conduct the experiment. We have talked about the setup of the experiment, why that particular things were only used to conduct the experiment, correct? Hope you remember that. We have talked about the observations also, and on the basis of those observations, what results he drew, what conclusions he drew about the atom also.